This is example 1.10, and the problem says the mass of a gold object is 38.6 kilograms and its volume is 2.00 liters. What is the density of the object in grams per milliliter? So we want our final answer to be grams per milliliter. Now, usually this would be easy, but our problem gave us kilograms for our mass and liters for our volume. So rather than trying to find the density and then convert it, we're going to go ahead and do our conversions first, and then we'll find the density. So we're going to convert our kilograms to grams and our liters to milliliters. Then we can find our answer, and it will be more efficient that way and less likely for error. So let's start with our mass. The mass they gave us was 38.6 kilograms. And let's add our conversion factor in here. We want to get rid of kilograms and turn it into grams. Just so that we don't mess up, let's put our conversion relationship. So for every 1 kilogram, we have 1,000 grams. All right, so for this, we're just going to simply multiply. For 1,000 being multiplied, the kilograms are going to cancel out. And we could just move the decimal place 3 times because there are 3 zeros. You could also use your calculator, but for the sake of time, I'm just going to 1, 2, 3. Just go ahead and move mine. Now we have it in grams. Did we change our significant figures? We started with 3. We ended with 3 because these 2 zeros on the end do not count, so we're good. There's our grams. Now let's do our other one. Let's move on to the volume. They gave us the volume as 2.00 liters, and we're going to change it to milliliters. So let's put our conversion factor in here. We get a little bit more room. All right, so we want liters on the bottom because that's what we want to cancel out, and milliliters on the top. Again, let's give a conversion factor. So we have, let's put it in a different color so it's not confusing. So we're relating milliliters to liters. Liters is big, so that's 1 for every 1,000 of our milliliters. So 1 liter for 1,000 milliliters. Again, you can probably just see that you would need to move the decimal. So 1, 2, 3. But we can't actually write it that way because it appears that we have lost some significance. In this number, we have 3 significant digits. The 2 is the significant, and then the 2 zeros are the end and after or to the right of the decimal place. So all 3 of those are significant. So in our final answer, all 3 also need to be significant. And so what we're going to do is we're just going to convert this by changing it to scientific notation. So we're going to put 2 point, and then how many zeros do we need? Still 2. How did we get here? We started here and we went 1, 2, 3 places. So that means it's times 10 to the 3. The 3 is positive because if we multiplied the 2 out, it would get to a much bigger number. So we want to make sure the 10 is a bigger number. And so now we have, remember our units canceled, now we have that in milliliters. So we have our 2 numbers that we need to work with. Now we can put mass over volume, which means we need our grams. Let's go back to my green. We need our grams, which is 38600 grams. And we need to divide that by our volume, 2.00 times 10 to the 3. That's milliliters. In this case, I would just put it into the calculator to make sure you don't mess anything up because there's no way you're doing that one in your head. 38600. We're going to divide that. I'm going to put this next part in parentheses because I'm typing in my 2.00. I could just type it in as 2000 because I know that's what it is and deal with the significant digits later, but sometimes your problem isn't as easy. So I'm going to type it in as a scientific notation number just so that you can see how I would do that. So you see how I typed in my first number, 38600 divided by, and then I put 2. My calculator removes the 0.00 because it realizes it just really is a 2 times 10, and the little caret means that that 3 goes up. It's an exponent. Anyways, so my answer, once I hit enter, is 19.3. So we have 19.3 grams per milliliter. Does this have the right number of significant digits? Let's check. This number has 3 significant figures. This number has 3 significant figures. They're the same, so our answer has to have 3, and it does indeed. It has 3 significant figures, so no need to round or change anything into or out of scientific notation. We can just leave it just like it is. If they ask for it in scientific notation, we would have to move the decimal 1 place to the left, and we would have to deal with that, but they did not ask for it that way, so we're going to give it to them exactly how they asked for it, 19.3 grams per milliliter. All right, if you have any questions, you can contact me or let me know in person.